Hi guys, welcome to Learn Electronics Repair. I have an amplified speaker here, active speaker, JBL 500 series. So this has a built-in amplifier, but to be more accurate, it has two built-in amplifiers. So this is what is known as a bi-amp speaker, two amplifiers. It has an electronic or active crossover, so when you feed the signal, i.e. music for example, into here, it divides it into high frequencies and low frequencies. The low frequency is bass, and you can alter the volumes here individually. We'll go to the woofer speaker, and the high frequencies will go to the tweeter. And the fault on it, also the customer tells me, is there's no audio coming out of the tweeter, only out of the woofer. So that could be caused by a number of things. There could be a problem with the speaker itself, the horn speaker, or the wiring to it. There could just as easily be a problem with one of the two amplifiers, the tweeter amplifier. Conceivably, there's a problem in the actual active crossover, so the tweeter isn't getting any signal, or rather the tweeter amp isn't, but that seems rather more unlikely. But you know, never put it past the realms of possibility, yeah? So I think the first thing we need to do with this is to power it up and just confirm the customer is diagnosing this correctly, that there's no audio from the horn speaker or tweeter, and then we'll open it up and have a look. Well, let's see. So we'll switch this on. It's powered up, it says signal. Okay, power. Let's just play some audio. Okay, let's see. Well, that's just an advertisement. And it sounds like just the bass. Yeah. Try my other Northern Soul track, one I normally use. Let's see what we have. Well, I can tell you only the bass speaker is working. The treble control has no effect, so we can say only the bass speaker is working. Okay, so the customer was correct in his diagnosis that only the bass speaker is working. Okay, let's have a look at this. Well, it seems, guys, I had to have a quick look. The only way into this is to take out the screws around here and then take the front off it. Okay, guys, so this is ready, I think. Let's see. Yeah, front comes off. The wires holding it together, I guess. Let's have a look. Yeah, I can see some wires. Let's see where they go. They plug in at the bottom. Okay, I've unconnected that. That's one set of wires, and the other ones go down here somewhere. Not sure. Let's have a look. Okay, I have it disconnected. Let's take this off. And there's something strange here. I mean, like, there's a whole bunch of components strapped on here, kind of like a crossover, and both speakers are connected together. That's never right. I mean, that's never right, guys. Yeah, what the hell have we got here? Bass speaker, tweeter. Let's have a closer look. So, this is where the connector plugged into, the 8-way connector, okay? And this is the front panel, so bass speaker, yeah, feels okay, the cone feels okay. Horn speaker, and this mess. So, like, this is obviously somebody's idea of a modification, or in fact they just lashed it together basically. Looks to me like probably the horn amplifier isn't working at all, so they've kind of like strapped all this onto the bass amplifier. Yeah, So that's the first problem with this for sure. Oh, and there's a nice splash of solder there as well. Okay, so this is clearly somebody's idea of a repair. How are we going to sort this lot out? Well, the only way to sort this lot out is to put it back how it should be, to be honest. Yeah. Let's see if the horn works. This is the one use I have for my analog meter. Yeah, this one. So you can see it's an analog meter. I have it set to bleeper. And it bleeps. Yeah. Now, when we connect it to a speaker, if the speaker's a good one, you'll hear the sound come through the speaker. Yeah. That's the meter. That's the speaker. So we know the speaker is good. How about the bass speaker? Well, quite interestingly, the wires disappear into the middle of it. Okay, we know the bass speaker works anyway because we can hear it. So really, not a lot of point, but just for the fun of it. Yeah. So we can put this back how it should be. That isn't a problem. The problem is, why have they done this? And I suspect there's a fault on the amplifier. So that's here. So we need to get this out. Let's see. I can see probably the signals coming from here. I'm guessing, yeah, this is like the little mixer board, yeah. The audio inputs that plugs into it. So these are the connections to like the little indicator on the front, which he said wasn't working. Well, one of them wasn't even plugged in, so that probably is part of the reason for that, yeah. So we need to get this out. Of course, the problem could be in here, yeah, but I think we should get this out. The chances are the fault is in here and not in the mixer. But we should be able to prove that if we can't visibly see what the problem is once we take this out. This proving extremely handy once again. That was a tight one, but it did it. I haven't recharged this, by the way. I've used it a fair bit. Not only on video, so. Okay. Okay. I'll probably have to move this little bit of tape. I think somebody's been in here before, actually. And here is our amplifier. This is the connector to the speakers. So that kind of like solders in down here. So I think we're going to have to take that out and this out. Okay, lots more screws then, guys. So here we have a power supply, basically. The mains power comes in here. We have the two large smoothing capacitors, the switch mode transformer. So this is a switch mode power supply. The MOSFETs are on the other side of the board. Effectively, this is one big metal heatsink, so they're underneath, pushed against the metal to effectively cool them down. But really, this is just a power supply. This then will be powering the amplifiers. Now, we have two amplifiers here. This is what is called a Class D amplifier, and you can see the red and white wires here. These are going to the bass speaker. A Class D amplifier, some people call these digital amplifiers, but they're not digital. It's really a pulse width modulator. So what this does is it acts like a pulse width modulator or a buck converter, and it's driving a load, and the load is a speaker. Now what a normal amplifier, if you like, does is just sends an AC signal to the speaker, positive, negative, and the cone will move in and out with that waveform. So it's doing this at whatever frequency the audio signal is, and that's what produces the sound. With a Class D amplifier, as I say, it acts more like a power supply. But imagine a power supply where the output can be varied, the voltage, continuously and very rapidly. So it's almost like a bench power supply, if you like, and you turn it up and down the voltage control, and you're altering the output voltage. That's what this does using pulse width modulation, but it does it very rapidly. Probably hundreds of kilohertz, something of that sort of frequency, so 100,000 times a second or more. It's sampling the input waveform, the audio, and it's altering the width of the modulation to match the voltage of the waveform. Okay, so what you get coming out of here is a continuously variable voltage, and that's driving the speaker. So it's like an amplifier, but it just does it in a completely different way. The reason we do this, by the way, is with pulse width modulation. The MOSFETs that are switching are either on or they're off. Okay, they're switching between on and off. And because of that, they actually dissipate much less heat. It's much more efficient than, for example, a transistor that's driving a speaker. So when the maximum voltage is going to the speaker, the transistor is fully on. When the minimum is going, it's fully off. And everywhere in between, the voltage coming out of the transistor is in between. But the supply voltage, think about this, supply voltage is the same. So if the voltage on the speaker is varying, the voltage on the transistor must also be varying. And the sum of the two voltages equals the supply voltage. This means that the transistors in an amplifier, class AB as they're called, or class B, are dissipating as much wattage as the speaker is. So the maximum efficiency at best can be 50%, and it's never quite that. That generates a lot more heat, so you need to have bigger heat sinks, heavier amplifiers. So this is why we use the Class D. I made an entire video on Class D amplifiers, in fact on all amplifier types and how they work, so I will link that to this one. So we have our bass amplifier. We also have the treble amplifier, the one for the horn. So you can see the yellow and white wires are coming here. They buy this chip, and this is the amplifier for the horn speaker. Now this almost certainly is going to be a normal linear audio amplifier, class AB. Because the horn speaker requires much less power, much less wattage, we don't need such a big amplifier, and it's okay to use something like this even though it's only 50% efficient compared to this thing driving the main power, because the amount of power is less, so it's not going to generate so much heat. So that's what that is. So now we know that, we have enough information to start working on the problem and finding out what is wrong with our amplifier. There are a number of ways we could go about this actually. We know the tweeter isn't working or not working properly, and we know that the wiring is being butchered, yeah. But from this board, we also know, or we should know, that this chip is driving the tweeter speaker. So why isn't it working? Well, we know the speakers actually work. We've tried them with the meter on continuity. They actually make a noise, so they are okay. Therefore, the next thing to do really is to break this problem down. I mean, what could be the problem with this chip? Well, basically, it could either have no supply voltage, that would stop it from working. It could have no audio input, that would stop it from working. Or it could just be a defective chip, that would stop it from working. And our job is to figure out where the problem is. And I think, although there's a number of ways we could do this, the quickest way is to look around this chip. We can see here, this cable. This is feeding power down into the preamplifier. The problem could be in there. It's also feeding the audio signal up into here. So we could put a signal in and look around here and see if we can find out which wire has got the signal. But if we can't find the signal, then we know there's a problem coming from there. To me, the easier way is to actually look at this chip first. So if we find a data sheet, we can find where the supply rails are, we can see if it's got the power as we mentioned, and we know where the audio comes in, and we can see if we got an input. And once we've done that, we should have a good idea where to go next with this repair. So let's have a look at this chip and see if we can find the data sheet for it. And there's the chip. It does have a number on, a little bit more light. Yeah, we can see it now, TDA7293. We should be able to find the data sheet for this, I would think. Let's have a look. Here is the data sheet. So we can see 100 watt DMOS audio amplifier. This is a mono amplifier. Of course, we would expect that because this is a mono speaker. And you can see internally, this is the power output stage driving the speaker. And this is, if you like, the pre-amplifier stage. And you'll see we have some supplies. So we have plus VS and minus VS. And we also have plus PWVS and minus PWVS. So this is the plus and minus supply to the pre-amplifier. Okay, pins 7 and 8. And then these are the supplies to the power output stage, pins 13 and 14. Now, in our typical application and test, you'll see that both supply rails are connected together, okay? We have a single positive voltage rail and we have a single negative voltage rail. But we don't have to. We could have a lower voltage driving the pre-amplifier stage and a higher voltage driving the power amplifier stage. We can see the pins here. So pins 7 and 8 are the power, plus and minus, and pins 15 and 13 are the output stage, plus and minus, okay? We'll look at some specifications. So they say in the supply rail, plus and minus 12 is minimum, plus and minus 50 is maximum. So to test this, probably the easiest thing to do first is to see, does our chip have power? Because we can do this with a multimeter. We don't need an oscilloscope to see if it has a signal. So let's check the easy thing first. If it doesn't have power, maybe we'll never need to test if there was a signal coming in. We resolve the power issue, it may well work. So the first thing I want to check is whether our chip actually has a separate or the same power rail on the pre-amplifier stage and the power amplifier stage. In other words, are pins 7 and 13 connected together, and the same with pins 8 and 15. So let's have a look. The power rails first then. We have the positive supply on 7 and 13. This is pin 1 with a square pad, and you go 1, 2, 3, 4, and so on. So we have 1, 3, 5, 7. And then we have 9, 11, 13, and 15. So 13 is this one. And they're connected together. So there's a single positive supply rail. So then you think there must be a single negative supply rail also. So that goes on pin 15 and pin 8. So 14, 12, 10, 8. Yes. So that's going to be easy to test the power rails on this then. We don't need to probe inside here. We literally have got supply rails on pins 15, which is easy to get at, and pin 13 is there. So the other thing we need to find then is ground. Well, ground will go to this chip as well. So let's have a look and then we can see where else ground goes to. Looking at the data sheet then. There's a signal ground on pin 4. I guess that will be our ground actually. Okay, it's the only one that is marked, and there's a standby ground on pin 1. These points are probably connected together on our board anyway. Let's see if we can find out where ground is. Okay, so this is pin 1, and I'm guessing this is ground. And it is, in fact, all of the bolts are ground. So we have a ground point. We have the test points 13 and 15, or 7 and 15. So let's see if our chip has any power. Time to take some readings then. The easiest way to do this is just to use one probe in your hand and click the other one to ground. So I've done that. These are actually ground, both of them. Okay. And actually, interestingly on this one, this is also ground. But this is on the kind of like the hot side of the circuit. I'm a bit surprised, but I guess there's no reason why it couldn't be. Okay. Put our clip man on here, that's good enough. This is connected, you can see to here, to pin 1, so we know that's our ground. Let's power this up then and see what voltage we have. Okay, powers on. Let's have a look. So pin 15. Minus 23 and pin 13. Plus 23. So our chip has power. Okay. If there's no load on it, which there isn't, the speaker's not attached, that chip should be quite cool. So let's just get the thermal camera while we're here and let's have a look. I mean, the other option is just to feel. It actually feels quite cold. But we can try with the thermal camera. Okay, we'll put this where you can see it. We'll switch it on and let's have a look. Oh, sorry about the reflection, guys. I'm going to find a better way. I know how I'm going to do this better very shortly, but it's not getting hot. So we know the answer to one question. Does our chip have power? Yes. The next thing then is, does it have any signal coming into it? So again, we'll look at the data sheet. Okay, and we can see that the signal comes in. This little squiggle here represents the signal, and it comes in on pin 3. If you look at pin 2, this is like the inverted input to the amplifier. You'll see that comes via a resistor to the output. So this is feedback. This resistor together with this one and this capacitor, which affects the frequency response, this will set the gain for the amplifier basically. If we have a look on pin 3, we should be able to find an audio signal if we put a signal in. Let's have a look and let's see if we can find an easier place to probe that. Well, actually we can, but to be quite honest, getting onto pin 3 wouldn't be difficult anyway, it's just here. But we can also go on the end of this resistor. So let's have a look to see if we have any signal getting as far as our amplifier chip. I have an audio signal connected, so let's switch this on again. You can see the oscilloscope just here, okay? It's working. So we will go on to pin 3. And we don't have anything there. We have a slight DC offset. There's no input. It's on 0.2 volts per division. So look at the output. Nothing. Nothing. So there's no audio in coming into the amplifier. So the question is then, where does that come from? Well, as we originally discussed, it comes in on this cable here. So let's have a bit of a nosy around here and let's see if we can actually see any signal. I'll just try to get into the shot. There we go. I don't know exactly where it's going to come in, but there's a lot of ferrite beads around here, FP1, 2 and so on. So I suspect this is the place to look. Okay, let's have a look. Well, there's something there, it went off. I'll set it is on AC, so it should settle back to the middle on the scope. I'll just turn the sensitivity down a little bit. Let's try that. It's like 2 volts per centimetre. Probe is on times 10, so yeah, it's 2 volts per centimetre. What have we got? Well, there you see now, yes, but there's no. Oh, maybe there is a little bit of a signal there actually. Give it time, I'm sure it will come back down. I don't see anything, if anything it's tiny. Let's go on the other ones. Again, I have to just change the range. That's a negative voltage with a bit of a something on it. Okay, there's something on this one. Nothing much. This one, I can get to it. Nothing much. And there's two more down this side. Nothing much. And nothing much. Maybe the problem's in the preamplifier stage. Guys, you can see I now have this in a much easier position to work on. So I was thinking maybe the problem is no signal coming in, but thinking about it, that doesn't make sense because the bass speaker's working, therefore the audio must be coming up here. I mean, conceivably, there's some filters on here, so it sends the bass frequencies up one pin and the treble frequencies up another one, but I actually wasn't seeing anything around here, and we know full well we have bass drive. It could be that this connector wasn't pushed in all the way, to be quite honest, so that's possibly me. We can have another look now. But when I removed the plastic cover over this part, I found that is actually attached to the housing, the ABS plastic, and this whole thing came out. So what we actually have now is the power coming in here, which goes to here. So we can apply our power here. We can power this up like it is on the bench now, and it's going to be a lot easier to work. So let's do that, and then once again, let's have a look to see if we have any signals coming in here. Another possibility is that we can see maybe from this board where the output is, and if we can see where the output is, that would also possibly help us. If we go to see the output anywhere, it's going to be marked on the PCB. I don't see anything on this side. But if I take this board off, it's just a couple of screws, I hope. Yeah, maybe a little bit more complicated than that. I'm hoping I can see markings on the other side of here. I've had a look under this connector with a torch. I can't see any markings that side, so I'm not going to try to take this off. I'm going to try to work out another way. So we know there are some inductor beads here, FB, this, that and the other, and I want to know if every cable in here goes to one of these beads or ground, or are there some tracks on the other side I can't see. So easiest way to do this, I think, is to take a piece of a pin header, stick it in here, and the first thing I want to do is figure out how many of these pins go to ground. Probably easy way, just clip a crocodile clip on ground, clip it onto the black lead, and then from this end, so this is pin 1 or 2 by the red stripe, if you like. Well, the first one goes to ground. Okay, so that's ground. Second one doesn't, third one doesn't, fourth one does, and the fifth one doesn't. So we know 2, 3 and 5 are not going to ground. Now we want to know, do they go down to here? Let's have a look. I'll probably take that back off actually. So we'll go to pin 2 on here. Okay, pin 2. And does that go to one of these beads? Let's have a look. No, 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 no. Yes, that goes to this one, okay? So that's accounted for. Pin 3 goes to this one, and then the one was pin 5, if you like. So that goes, there's one on the edge of here. Yeah, not that one. No, no. This one. So we know those 3 pins which are not ground go to 4, 5 and 1 there. And then we can look on the other side. We'll do the same thing. So first of all, we'll look for ground. No. Yes. No. Yes. No. So 2 and 4 this time are ground. So again, 1, 3 and 5, we need to see if they go to these beads, okay? So we'll go from pin 1 again at this end. Of course, they're not both pin 1, but I mean this end, yeah. So that goes to one of the beads. Yeah, that one. Okay. 3. Well, 3 goes to there. Does 1 also go to there? No, one goes to this one. So 1 on 5 and 3 on 6. I wouldn't be surprised if these two are the signals. And then the other one must go to 2. Okay, so we know we can account for every signal on this cable by probing here. Now what we're going to have, we're going to have voltage coming in. We're going to have ground, we know that, but none of these beads are on ground. So we're going to have a plus and minus supply. We're going to have a signal coming out and a few other things. Let's check. So now I'll make sure I plug this into the preamp correctly. Well guys, it's another day, another polo shirt, yeah. So in the interim, since yesterday, I actually decided to have a look online to see if I could find a schematic for this amplifier. And actually I could. So I'll show you where I found the schematic and then we can have a look at it. The site I found the schematics on is this one. So it's Electro Tanya. Okay. This is not an English site, although often the titles of the schematics are in English. You'll see there is a forum on here, quite active forum, so join here guys. You can request schematics and such like. I'm not actually logged in at the moment. If you are not logged in, you can still download schematics from here, but you can only download up to 5 per day, okay? It's a very useful site, so have a look at this one guys. And I found here the schematic for this amplifier, or rather amplified speaker. And here it is for the JBL EON 515XT. We have a troubleshooting guide, we have the schematic parts list, the mixer schematic and so on. So here is a power amplifier and here we have what we need. We can see now, by the way, the power transistors all mounted on the other side of the board as I mentioned. And if we look through, I'm interested to look at the amplifier for the horn speaker. We'll just make it a little bit smaller so we can see the schematic sheets properly. Okay. And you can see, just I'm going down here, so we have LF in, plus minus. This is 2 of those ferrite beads where I had my oscilloscope. So this is where the signal comes in from the base, okay. Feeds into the amplifier. And the other amplifier is this one, HF in, plus and minus. So this is what we want to look at. Now I know exactly bead 3 and 4, FP3, FP4 is where we should find a signal. We can just make this a little bit bigger, okay. And you can see that comes into this chip U401, which is an op amp. Coming out of here, we have a signal driving into our amplifier. Now it may be that the signal here is actually very small on the input of the amplifier, which is possibly why I couldn't see a signal, but the signal coming out of here should be much larger. So you can see this goes through a resistor, an electrolytic, who knows, is the problem, through another resistor and into the power amplifier for the horn speaker. So a good place to look is going to be here. U401 pin 1. We'll put a signal in again. Do we have anything here? Okay. These resistors here, by the way, you can see some very specific values. 2.49k, 2.49, 3.65, 825, 825. These effectively set the gain of the amplifier. This capacitor here is also involved with the gain, but the gain varies at frequency. So with a capacitor, this is a small one, 220 picofarads. More current, AC current, will flow through here at higher frequencies. So what this does, wired across this resistor, is effectively reduce the value of this resistor at higher frequencies. The higher the frequency, the more it reduces the value. And you can see that is the same value as this one on the input. So this means effectively at higher frequencies, this becomes a lower resistance. So this amplifier has more gain at higher frequencies, which is exactly what you'd expect for a horn speaker. Okay, another thing we can just look at now while we have a schematic, there is a mute signal on our amplifier here, which is controlled by this little MOSFET. Mute, so we could test to make sure it is not muted. So it's showing a high voltage on here is mute, low is run. So low will switch this off, so the voltage here will go high to run. Now if you look, this has a 15 volt supply, whereas our amplifier is plus and minus VCC there, okay, but the op amp is also 15 volt supply. So it could be a problem with the 15 volt supply that's causing this not to have a signal. So that's something else we should look at as well. But first of all, I want to know if there's any output here. And if not, does this chip U401 have any power, which is on pins 4 and 8? You'll see this is a dual op amp, U401B, and the second one is not used, so it's kind of linked to itself, to ground. It's effectively bridged out, if you like, so that stops any stray oscillation or anything in this chip. That's why they've done that. One other thing while we're here, I will just mention, because I've never seen it before, U401A, U401B and U401C. When I first glanced at this, I thought, oh, 3 op amps in this package, but you don't find 3 op amps in one package. Usually you find 2 or 4. So I thought, oh, this must be a 4 op amp, a quad op amp, therefore it's going to be a 14 pin chip at least, and I couldn't find it. And the reason being, it's actually an 8 pin chip. It's just a dual op amp, A and B, and they've called the power supply U401C, just to confuse me, I think. Okay, so enough of that, guys. We know where we're going to look. Pin 1 on here is an output, and pin 4 and 8 on here, does it have a supply? Okay, let's do it. Okay, guys, we have the oscilloscope there. We'll just switch on. Okay, the audio actually comes in here on this jack connector, and we can see we definitely have audio there. So we know we've got audio as far as there. Let's go on these ferrite beads again now, so we can see FB4 has a signal on. Sorry, FB6, that's the base, and FB4 doesn't appear to have anything on it. So there seems to be a problem with the signal coming out the preamp. So we can go on to pin 1 of our op amp, U401, but I'm expecting to be nothing here either. Yeah, because there's nothing coming in. FB4 doesn't have a signal, so without doubt now, and there's the base signal, we know the problem is no signal coming out the preamp. I have the schematic for this, but unfortunately it's not the same as the board I have. So there are some parts on the schematic that do not exist on my board, and there's no place for them to be, so it's not like mine is partially populated. It appears to be, in some extent, a different board, but in other extents it seems to be similar. Let's have a look and I'll show you why it's different. Here then is the schematic for the mixer, which doesn't really match the one I have, and I'll show you that. But in other ways it's very similar. So we have the main balanced input, aux input 1 and 2. I'm actually using aux input 1. And you can see that each of these inputs goes via an operational amplifier here, 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 into the volume control for each input, and they're all connected together. And this effectively is the mixed input from the 3 channels. So you can have music and a microphone, for example, coming into here. And that goes into this amplifier stage. Okay. And that feeds again to another amplifier stage. And that then, which is the mixed signal, comes into this network here. So you can see we have tone control and high pass. High pass would basically mean the high frequencies go this way. Tone control, well, I guess you can alter the tone here with some sort of control, though I don't see it, okay? And these effectively come into this switch. Now, we don't have this switch on our board, switch 5. Also, you'll see here U4. We don't have U4. It doesn't exist on our board. So some of this is not present. Coming out of this non-existent switch, then we have mixed signal, okay, after the tone control. And you'll see that goes to a couple of places. So one place it goes to is the pass-through. So this is an output to another speaker, another amplified speaker. And the other place it comes to is here, mixed signal. And this now splits two ways. So you can see it comes this way and it goes this way. Now if we look at these parts of the circuit, this is where the audio is filtered into the high frequencies for the horn and the low frequencies for the woofer. So mixed signal into these operational amplifiers. Yeah, there's also a little potentiometer here. This is on our board and it's actually a trimmer pot, okay. And after processing through this circuitry, we then have some output. So we have high frequency channel negative, high frequency channel positive. This is the signal to the tweeter, and this is what's missing. If you look at this, it looks like effectively ferrite bead, that these two are shorted to each other. But in actual fact, on our board, only two of the beads exist. I can show you, but it was number 9 and number 12. So these two are not actually there. Therefore, we just have high frequency channel negative and high frequency channel positive. This is the signal on the 10-way ribbon where we have looked and we don't find a signal coming out there. The other signal path, well, it goes through another set of operational amplifiers, and that eventually generates this one, low frequency signals, a low frequency compressor. And we can say after that it generates low frequency channel positive and negative. The other thing you can see is this. So this is the 10-way connector. We have high frequency channel negative, high frequency channel positive, and the same for low frequency positive and negative. So those are the signals going to the main amplifier. The other thing you'll see here, we have plus and minus 15, okay? And if you look, there was 1, 2, 3, 4 pins connected to ground. And we know when we were first tracing this out, we do have 4 pins connected to ground, and the others go to various ferrite beads. So that's what we have, but as I say, our schematic and our PCB don't exactly match. But there are some very useful things we can take from this. First of all, we know we have bass, okay? So therefore, all the input must be working. All this really, as far as mixed signal here, must be working because we have bass. We have, and we've heard it, from here, mixed signal through this path to the bass, and that works. So that tells us basically that we have a signal containing the high and low frequency as far as here. But we don't have a signal coming through this lot. There's no signal on these ferrite beads on the connector. Now there are a few things that we may want to check here, in particular things that are likely to go wrong, and one of them is, for example, this variable resistor. Variable resistors do fail, they go open circuit on the track, so we can certainly test that because it's just a likely thing to go wrong, okay? We also have on our PCB the bass and treble volume controls, so we should try to locate them on the schematic from the part number and check there as well, possibly the treble volume controls open circuit. So the first thing I'm going to try and test is whether or not those potentiometers are okay. Another thing we should test is any switches. Now we do have some switches on our board, which you can see here, okay, 1, 2, 3. But these switches, if we look, one of them is the mic and line input for channel 3, and we're not using channel 3, so really that isn't relevant. And we know we have an output coming from the mixer stage. This one is mix and loop, and that effectively is the signal to the next speaker, the next powered speaker. You can either just send the input signal directly through or the output from the mixer directly through. So again, that isn't really relevant. And the last one, turns the JBL logo on the front of the speaker on or off. So none of those switches have any relevance in our instance to the possible fault on this unit. We know the mixer input works. So this is the one I'm very interested in because this doesn't do anything, okay? The treble. Let's have a look at it. This is it then. This is VR7. We can look that up on the schematic, but let's just see whether or not it actually works with the multimeter. And I have that there where you can see it. So we'll just check this. We should read across the track the resistance of the track effectively. So that's reading 18k across. I'm not sure what value this is. We go to the middle from one end. That's reading about 10k. The other end about 9k. And then if we adjust this, it should change. So I've gone all the way over to one end. That's now 0. All the way back to the other end. That's now 0, so that appears to be working. I'm thinking one end of this probably goes to ground. I'll see if I can find it on the schematic, but let's have a look. So this is ground. No, in actual fact it doesn't. It was just a thought, so that's obviously wired somewhere in the feedback network of one of the op amps. Let's see if we can find this on our schematic, VR7. Unfortunately, the schematic is not searchable. Control F. VR. Yeah, it doesn't find it, so it appears not to be searchable. It's probably just a JPEG effectively, not a PDF document as such. Let's see if we can find it. Well, we pretty much know it's somewhere in this high frequency circuit. I can see VR5, that's the little trimmer which we're going to test in a moment. And this, guys, is where we start running into problems because VR7 does not exist on the schematic. We have VR5, which I'm going to look at the moment. That is certainly in the path, which I want to see if I can find the fault in. I think the fault is here somewhere. We have VR234. These are the input volume controls for the 3 channels. They're on our board. But VR7, and for that matter VR6, which is the bass control, neither of them exist on here. This is why I say it's not the same as ours, okay? So, as I mentioned, VR6, VR7 don't exist on the schematic. VR5 is there, this yellow one, okay? So, we can test that, just to see if that's any good. So, we have one end of it. This is a 2K, so it should read 2K across it. Okay, it reads 1K, but that's not unusual to read a lower end circuit. That actually reads 0 to that end. Or was I just shorting on the metalwork? No, it is actually reading 0. It's coming from this side. Okay, and the other end was reading 1K. So let's just see if that is actually positioned at one end. It should be according to that. See if this will fit it. So, well, no, it's not positioned at one end. It's like there's a short somewhere there. You see it? That's in the middle position. If I move it to this end, okay, from the wiper, which is here, to here, is reading basically 0. But it's also reading basically 0 to that end of it. Okay. Go the other way. That reads open. Right, the reason it's reading like that is because one end of the track is connected to the wiper on the schematic, okay? Go back to the middle.
Okay. Onto the wiper. Yeah, so this is actually okay. I think it's just that the wiper is actually attached to one end of it anyway. So when you move the wiper to this end, it leaves like a short across the track. Okay, that's fine. So that is actually working. It looks then, there's nothing obvious. There are one or two other things we can check, I'm thinking, actually. But what I think the best thing to do with this is to actually power this up on the board. So connect the plus and minus 15 supplies to it, ground to it, stick a signal into it from the signal generator, and just work on this board on the bench. It's easier than working on the whole thing assembled, and it kind of precludes any possibility you might do something here, cause some sort of DC offset and damage the main amplifier, which is not what you want to happen. Yeah, I have this all set up so we can test a few things here now. This is just a piece of a connector, if you like, off an old ATX case. So I have connected here the plus and minus 15 from my bench power supply. The green and yellow wires are actually connected together, and that is ground. I will show you that in a moment. I have coming in here a signal. So this is connected effectively to the input I was using with the jack plug before. The red is the input, if you like, and the white is ground. And connected to that is my signal generator. So here you can see the signal generator set to 10 kilohertz. That's a nice high frequency, so this should come through the signal path we're interested in. To complete this test setup then, I have the power coming in. So these are coming from my bench power supply, plus and minus 15, and this is the ground or 0 volts. I have that attached onto my oscilloscope, so that is grounded, and this is the scope probe I'm actually going to be using. Here is my power supply. This is a dual power supply. If you don't have a dual supply, you could have two single supplies and connect them in series. So you effectively connect the positive one supply to the negative the other, and that becomes your ground, and then you have plus and minus voltage outputs. I happen to have a dual one, so we'll use that. And you can see quiescently, this is drawing, well, 80 milliamps on the negative supply and 70 milliamps on the positive supply, okay? First of all, let's check to see if we have any signal coming in from our generator. Yes, we do. So the setup is working. We have a signal coming in. Now, where should we check in the circuit? Well, probably the best method to use here is like the 50-50 split. So we go halfway through the signal path and loop there to see if we have any signal. In our case, the signal is coming in here, okay, and forms this mixed signal, and then this is the audio path for the high frequencies, the one we're interested in. This is the low frequencies. So a good place to check is the first op amp in the high frequency signal path. Now, when you're checking for signals on op amps, check on the outputs. The chances are on the input you won't see a signal, or it'll be extremely small. Depending on the configuration, you may actually not see a signal at all on the input, especially the inverting input, but you may still have an output. Now, that will sound strange. I'm going to make a video on op amps to explain this rather strange situation. But for now, let's just check on the outputs of all the op amps, working our way through to see how far the signal goes before it disappears. The first point then is going to be U14 pin 1. And on our board, U14 is here. So this stripe is pin 1 here. Let's have a look. Well, we have a signal getting that far, so that's so far so good. Where else should we check? Let's go back to the schematic. The next point I'm going to check is about halfway along again. Let's go here. So this is U15. Pin 1. This is where the little trimmer pot was, so it's easy to get to. So let's see if we have a signal there. U15 pin 1, or just on this end of the trimmer pot even. Let's have a look. Well, that's here, U15. Again, we can see the stripe on the top of the op amp, so this is pin 1. And we have a signal. Okay. That should appear on the trimmer pot as well. Yeah. So we have a signal as far as there. Well, there isn't much further we can go now. Let's have a look. Well, in fact, there's only one more op amp. So pin 1 on U21. This is HF negative and positive. That actually also goes to the connector. So yeah, let's have a look on the ferrite beads. FB9, FB12. And those are actually here. FB9, FB12, just these ones. What have we got? Well, we have a signal. Have we got a signal coming out of this? Yes. Yes. So this is working. In that case, if I alter the volume control on the treble, it should change the amplitude. Let's have a look. So I've just got hold of the volume. Let's see what it does. So this is FB12. That will do. FB9, FB12. Yes, and I'm changing the amplitude also with the pot. So this is apparently working. I'm sure I tested before the continuity on the cable from here to the other side, and I'm sure it was good. So either this is working on the bench power supply and it's not working on the built-in power supply of the speaker amplifier, or there is a bad connection in this cable because the other end we definitely didn't have a signal, or just possibly the fault was this trimmer pot. These do fail quite often, and they sometimes have like a dead spot on the track, so they're not making a connection. And it may be just by adjusting that backwards and forwards I've actually got it to work, okay? But I moved away from the dead spot effectively. What I need to do now is connect this PCB back up to the main amplifier, put the signal in the same as I am doing, and see whether or not that actually generates a signal into the horn amplifier. I've put this back together, so what I'm going to do now is to sort out the wiring with a horn speaker, this mess we looked at earlier. This thing, yeah. Remove the strapped on components and connect the horn back up. And then let's power this up, put a signal and see if we get any audio out of the horn. We know now we have a signal here where we didn't have, and previously on the video I actually tracked through all the connections on the cable and made sure that they were all there, so it should work really. Well, that's the theory anyway. Let's see what happens. I've removed the insulation tape off here, so now it's time to unsolder this lot. I want to make some effort to try and get these wires the right way round. They are actually marked, so we have green and black, green and black, and we have green and green, for example, so that's okay. That means we know which wires go where on here as well. I'll be best just to add some fresh solder. This will come off easier, I would think then. Okay, so a bit of fresh solder. Let's see. Well, they actually made this quite difficult. I think they've wrapped the wire round. So the easiest option, I think, is to actually cut these off. Okay. Take this one off also. So that's those. And I'm just looking at these now. I think basically they haven't cut the wire. I think they've actually just stripped off some of the insulation. Let's have a look. Yeah, I think they're twisted around each other. I'm going to do the same with these because I need to put insulation on. I'm not just going to use insulation tape. It's very amateur that way. So we will actually cut through these. And I'm going to use some of the solder stick connectors. They're ideal for this sort of repair. These are solder stick. These produce a watertight insulated connection between two cables, exactly what we want. So we'll take some of these. They're in various sizes. I think this is probably the correct size for our wires. We can have a look. And then we're going to insert the wire. Okay. I think I'll actually just remove that tinned bit. Okay, we have it. Let's insert the wire into the solder stick connector. So this is the green wire to green. We just push these into the center like so. And then we need to heat this up with a hot air gun. Okay. We'll melt the solder first in the center of the connector. That will tin the wires. There we go. And then we can just melt the coloured band, the blue band. This is the glue, which will hold all this together. Okay. Just give that a few moments to cool down. And there we have a good, insulated, strong connection between the two. Let's do the same with the other one. No need to tin the wires. Just insert them. No possibility of soldering it first and then realising you forgot to put the heat shrink sleeve in over the end of the wire first, yeah. Just heat the solder. Melt the glue, and this is also a heat shrink sleeve as well, so it's like heat shrink with glue and then the center solder. Okay, once again just wait while that cools down, and you can see we have a nice strong soldered joint there, all insulated, nice. Let's do the same with these. So this one, we actually need to fix these twice because they've also been cut here as well. And I don't really want to shorten the wires. Okay. We can do this end first. Same principle, just trim off the soldered bit. We have the blue and black wire, blue and black, okay. Solder stick connector. Inserted. Once more. Okay. I'm sure you can see, guys, just how easy this is. Actually, these connectors are a very handy way of doing this. So I will solder the other wire and then remove these power resistors and just fix the wiring up. And then we can test the speakers. That's all sorted then, thanks to solder stick. Nice, neat job, yeah. So let's connect this back up and see if it works. If not, we can trace the signal more, but I'm confident now we do have a signal getting to the main amplifier. This is the little network I removed from the horn speaker. So basically we have here a 100 ohm resistor, 28 watts. We have a 4 ohm resistor, probably 10 watt or maybe 20 watt. And we have what looks like a 3.3 microfarad 100 volt non-polarized capacitor. So maybe I'll get to keep those as well. Bit of luck. Right, let's try this. I've balanced the amplifier onto the speaker. I've connected the speaker wires to it. So let's put some music in and see what happens with it now. What you can hear the difference, guys. Well, you can hear the difference, guys, yeah, and that's with it lying down on here. So we've definitely have the high frequency speaker working now. To save bothering just to connect the oscilloscope and everything back up again, I've actually now just unplugged the horn speaker. You can see it there. So again, let's put the same music. Yeah, no treble. Okay. Switch it off, reconnect the horn. Okay, reconnected, back on. And there you go, guys, obviously working. I need to reassemble this. I'll have a look to see if I can find another one of those trimmer pots in that style. It's a common value, 2K. If I can, I'll replace it. Although, to be quite honest, this will probably work now. If it's a dead spot on there, which I'm only suspecting was the problem, but it seems the most likely one, then just by moving it, probably work for years. I hope you learned something from that one, guys. It wasn't necessarily a difficult problem, but it does help if you know about that type of fault. But in particular, I hope you've learned something about the method of actually diagnosing this, how to go about it, that's the thing. I'm sure some of you will have your own methods of doing that. Comments below, guys. All I will say, and you know I am of this opinion, there's no right or wrong way with this. Yeah, some ways may be quicker than others or whatever, but to me there isn't a right or a wrong way, there's just a way that works for you. But let's talk about it, okay? I look forward then to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.